Hi everyone, thank you for joining us for the final session in the Polkadot Educate series. Throughout this series, we've been looking at all of the topics in Polkadot 2.0, but now we're looking forward to Jam. So we have Filippo from the Web3 Foundation joining us today for this workshop. Whenever you want to share your screen, Filippo, we can.
Yeah, sure. Hi, thanks for having me. This is a presentation about Jam, this join accumulate machine that has been introduced by Gavin Wood this year, officially introduced during Sub-Zero and then later on at Token 2049 in Dubai. So this join and accumulate machine, I think the best way to present Gem is to also talk about the roadmap to Gem and see why we are getting there and why Gem is a good solution to the current landscape and blockchain landscape. So let's start and let me see here. Okay, so the first thing to understand, just it might be a little bit technical, but this is just to understand how Polkadot currently works. We have these cores. These cores are the hardware, and this is basically at the bottom, you can see. And then above this core, we have this kernel. This actually input and output, how these cores are utilized. The thing is that I want to make the analogy here with traditional computers. People nowadays knows that each computer are a processing unit, as a CPU, and this processing, this computing unit can have different cores in order to speed up computation. Yeah, people know about dual core and quad core and even more nowadays, right? So this is the analogy that I want to do here throughout this presentation. This analogy of comparing Polkadot to a computer. And because in the end, it is actually a decentralized kind of supercomputer, right? So here it's just to show that this kernel currently is very fat and contains a lot of things. We have the staking, we have the governance, we have the parachains, these rollups, because Polkadot is providing security to this parachain. That I don't want to use the terminology parachain. I want to use something that is more close to the Ethereum kind of world, and it is essentially rollups. And then above this protocol and then staking, we have this user kind of domain, and this user domain is actually the parachains. And with user, I mean not necessarily the end user, but also developers that are actually building these parachains. So this is actually what Polkadot is, and it's nice to have this in a picture so that you guys can remember a little bit how it works. So the CPU analogy, essentially what I said is Polkadot is a multi-core CPU. It's essentially a roll-up processing CPU. It provides security, and we'll get a little bit more in detail with this. It's currently one core and one roll-up. It means that each roll-up right now is connected to a core. It's kind of a fixed connection, quite limited, as you might already think about. But it is the current state, and we have currently 50 rollup, of which 5 are system chain. And this is actually like a computer, right? In the computer, you also have system processes. In Polkadot, you also have system chains. And this system chain on Polkadot are currently the bridge hub. And this is actually very nice because now we have also Snowbridge, which is the bridge between Polkadot and Ethereum. And the bridge hub contains a light client that is actually verifying the Ethereum state on Polkadot. So this is actually quite interesting to see like how these system parachains are already being used. We have the collective system parachains, and already contains collectives. We have the technical fellowship, which is a broad group of people with different technical experience. It's a ranked group. We have different levels. And essentially the fellowship it's there to provide technical kind of expertise in Polkadot, and is actually paid by the treasury. So we have the salaries that directly paid from the Polkadot treasury to the fellowship members. Then we have the Asset Hub. This is probably the most common system chain on Polkadot. It's the most known system chain because we have NFTs and a lot of decentralized apps already work with the Asset Hub. A lot of wallets also have Asset Hub integrated. You can see your NFT in the wallets and so on. We have the People chain that is about identities. Currently, you can set your identity on the People chain. And then we will have the Core Time chain, and the Core Time is all about how we can manage in the most agile and efficient way this computation, these cores, right? Okay, what about this core? These actually are illustration that I'm working. It's a work in progress. I want to show this. This is basically the draft, the backbone of what it will be the final illustration, but I think it's already very explicative and very nice to show for this presentation. Polkadot essentially has validators. There are currently around 1,000 validators, but not all the validators are entering the active set. And those that are entering the active set are around 300. And these validators are the ones that are producing blocks every era. So how this validator actually work is that some of them, they are part of these cores. So some of them, they're actually guarding. You can see these circles on the top of these cubes. Each cube is a core, and this validator are actually 5 of them. They are guarding each core. So they basically sit on the top of this core. But cores are dynamic. It's not kind of fixed, you know, like it must be secure. So having the same 5 validators on top of each of this core, it might be risky, right? Because this validator can be all malicious, for example. So what happens actually is that these 5 validators, they rotate between cores, right? Every now and then they rotate. If I remember correctly, I think it's every minutes. I think they rotate, and then every 4 hours they change the core composition. You can see here these validators, these circles, they actually get reshuffled and then redistributed again to these cores. So this is actually what's happening, under the hood. These cores are not static, but they're very dynamic, and these validators are changing all the time. Yeah. By the way, if you want to know more about this system, there is actually the Polkadot wiki that I will show the QR code at the end of the lecture. You can learn more about this. This is actually not the whole story, but essentially the rollup system that Polkadot is offering makes sure that the security of these 5 is as secure as the whole validator set. And this is done with data availability system and also with a cryptoeconomic kind of system, and also an escalation system that calls more and more validator if there are some problems. But we will see this later on. This rollup that Polkadot is offering, I think it's very important to understand that is a cynical rollup. Everything gets checked. It's not an optimistic rollup, because optimistic rollup works in a way that it's not necessarily true that everything is checked. If something bad happens, there can be disputes, but everything is not checked all the time. So here is interesting to see that Polkadot, how it works, is that these cores are actually checking everything. So these 5 validators are actually receiving the data from the rollups. So these are the data that is coming from the Parachains, from the rollups. Then when there is a quorum and it's all fine, what happens is that one block author is writing into the Polkadot blockchain, into the state, that this data has been backed. But it's not the end of the story, right? Because there is an additional step which allows everybody to know what is going on in the different cores. because here there is the example, for example, the example of 2 cores. Now you can see that the cores are occupied after the data are backed into the Polkadot blockchain. What happens is that the core becomes occupied, and there is this data availability system is sharing data between the cores, right? So essentially, all the validators knows what is going on in the different cores. This is very important because if something happens, everybody has this data available to check. And this is important for the escalation process. It's true that only a minimal part of these nodes, they check everything, but if somebody notice something wrong and there is a dispute, everybody, all the validators, also those that are not in the cores, can check this data. And in the end, if all is okay, another block author is including, this is the inclusion process, is including this data in another relay chain block, so in the Polkadot blockchain. So this is the very important process that is in Polkadot, right? This is actually the core of what Polkadot provides. Polkadot provides this cynical rollup. It provides security. It always checks whatever is coming from this rollup, and if all is right, it put this data into this shared state, which is the Polkadot blockchain. But I would like to go and do a little bit more of a focus, a little bit zooming out, and essentially showing how a core actually works, right? So right now, there is a connection that is permanent, essentially is permanent, because we still have these auctions. So how can we access this computation that Polkadot provides, this service? The only way to access this service is to win an auction. So the highest bidder gets access to this computation, get access to one of these core. As you can see, it's not really a very inclusive process because first, the resource is very limited, and only the highest bidder can access to this core. But the highest bidder might not be the person that actually, develops the end platform or the dream use case. So we want to make this system more agile, and I will explain a little bit later on, like the solution. But now let's stick with this permanent core chain connection. You can see this chain is connected to this core. It's a fixed attachment point, and here is essentially kind of diagram, a representation of the load on this core, right? On this core, there is just one chain. It's the same chain all the time, and if this chain utilizes this core and has a lot of usage, then the resource that Polkadot provides is well utilized. But it can be that one of these chains is not really able to utilize this computation at the maximum of this, at the maximum possible computation load that it offers, right? So this is also kind of a little bit of a problem because we want to make sure to use this computation as efficient as possible. And this is again another representation of what is going on. We could have core 1 and core 2, and it's one core, one chain. And you can see, for example, in one core, we can have one rollup, and in another core, we can have, for example, a system chain, like, I don't know, the bridge hub or asset hub. So this is similar to what is going here, right? So let's talk about flexible core chain connection. This is actually the solution that agile core time. I don't know if some people in the crowd already know about this, but we are slowly transitioning from the auction model to the agile core time model. Essentially, the current state is that you have to win an auction to get access to a core. You have to lock some dots. This dot can come from donors that they actually helping you to win the auction, and in exchange of this, you can give tokens, for example, right? This is also a system to distribute your token, right? This flexible core chain connection is a little bit different in a sense that now, if you want to access this computation, you have essentially to buy time on a core. This is where core time comes from. You have to buy your time on a core. You get this core time NFT that allows you to access that core for a specific range of limited range of time. The sales, the dot sales for this core time, from this core time revenue will be burned. So it will create kind of like what to say, like a revenue for the blockchain. And it creates some interesting possibility here because in this diagram you can see how we have now two chains that can connect to that core, but not at the same time, never at the same time. One possibility, for example, is that for chain one maybe has access to that core, but realizes that it's too much computation. So what we can do is we can interlace the core time of chain one. Chain one can interlace its core time with a chain two. So you can see here the interlacing process is that in one specific 6 second slot, for example, which is the block time for the Polkadot relay chain, it's chain one, and the next one is chain two, and then chain one, and then chain two, and so on. We are interlacing this core time in order to use that specific computation on that core, that resource, as efficiently as possible. This is like kind of a concurrency kind of possibility that Polkadot allows. And the other possibility is splitting. So we can actually split the core time and say, okay, I will use this core until time X, and then after that, it will be chain two, right? I will completely detach myself. Maybe I will go on another core. I don't care. But from that time on, from X onwards, it will be chain two that will have access to that core. You can see how this is becoming very, very, more flexible situation, and also more inclusive, because now you can have multiple chains accessing accessing one core, depending on the on the workload that they have. They might decide to split or interlace, and it creates really a very agile environment. And again, here it's another another representation that shows, for example, we can have the splitting, and with the splitting can be like maybe one rollup is using it, and then the next period is a system chain. Or we can the interlacing, right? It's like a system chain and then another rollup. It doesn't have to be like a system chain. It can be two other rollup that are not system chains. Just I think it's nice to see like the the system chain together with a parachain, with a rollup. Another feature that is coming to Polkadot is elastic scaling. Elastic scaling essentially is multi-core computation. Elastic scaling provides the possibility for one chain to use multiple cores, and I believe it's up to 3, maximum up to 3 at the start, at the same time. So this can be the example of a chain that already uses a core and is using it at the maximum, is using all the computation that is available. So it needs an additional core in order to to scale. Otherwise, it's not possible, right? It can be maybe a gaming platform or a social media platform. Those kind of applications that they have a lot of transaction, a lot of activity from users. But you can see here in this diagram, we can have core 1 and core 2. And on core 2, there can be an interlacing, for example, with another chain. So this application in green here is using core 1, but is using core 2 with another chain. And it's using elastic scaling and is using also agile core time on core 2 and is interlacing the process with another process, for example, here, a system chain. Another thing that is, if you remember the first sketch that I showed, there was a really fat kernel where we have the parachain protocol and everything. And you can see here the transition that Polkadot is doing. This is minimal relay, right? For example, a good example is that the Polkadot identities originally were in the kernel. Polkadot identities were on the relay chain. And it's just a couple of weeks that Polkadot identities have been migrated to the people's chain. So this is a migration that is taking out a lot of functionalities from the kernel that can be, offloaded at the edges of Polkadot on Parachains. And this allows the kernel to be more simple and concentrate the effort on what Polkadot does best, which is this rollup system that I described at the beginning, this security system, right? And I would like to, have a little bit of a summary here and show what is Polkadot 2.0. Polkadot 2.0 that has been voted through OpenGov is Polkadot that has agile core time, has elastic scaling, and asynchronous backing, which is a little bit like the backing process that I described before. It's a very efficient way of having this backing process that is already live on Polkadot, but I will not go in detail in this. But here you can see how the system is very, very agile in utilizing, in using these computation sources, these cores. The example here is a quad-core computer. So I would like to represent Polkadot like a quad-core computer with 4 cores. And in here, you can see that guarding this core, there are like 5 computers. These are like 5 different validators on each one of these core, right? And connected to this core, there are like 4 chains, chain 1, chain 2, chain 3, and chain 4. So what happens here that is represented is first, 2 cores here are shown as occupied, which means the backing has already happened, and they are distributing data outwards towards all the other cores, all the other validators. You can see like we have core 1 that is distributing data to core 2, to core 4, and core 3. And the same is core 4, right? Because it's occupied, it's in the availability process. So it's distributing data outside, right? But also here we can see chain 4 is permanently connected to core 4, but is also connected to core 2 and core number 1. So it's essentially using these 2 cores together with chain 1 and chain 2. While chain 3 here is just using this core on itself, right? So here I just wrote, occupied cores start distribute the data to other nodes, and this is the availability process. And here we can also see that the feature of elastic scaling and agile core time, which is this way of utilizing the same core intermittently with another chain. And sorry, okay. And here the task manager kind of tab, like in your computer, that shows the CPU usage, right? In core 4 has the chain that has a lot of load. It has 100% full load. So what it needs to do is using together with chain 2, core number 2. And here, for example, I put that is splitting. So chain 2 was using the core for some time, and then chain 4 started to use the core. And chain 4, it's also using core 1. And in here, I just showed the interlacing process, right? Instead of splitting, we have interlacing. So here we have a nice representation of not only elastic scaling, which is like chain 4 using 3 cores, but we also have agile core time, which is chain 4 that is using this core together with other chains, but not at the same time, right? It's either one chain or the other. And core 3 is just chain 3 and is using its core on its own. So I think it's very important to have this picture in your mind and see like how Polkadot, it's a very agile. It provides a very agile way for this very high class kind of enterprise grade computation and security. But it's not perfect, right? Polkadot has not been a perfect solution, and this is normal because Polkadot is a pioneering. It's a pioneer in the industry. It's providing a lot of solutions that are very new, and with these things, it also comes a lot of risk all the time. And it's important to understand the whole trajectory of Web3. We have Bitcoin that provided a very resilient way to transfer value without intermediaries using blockchain technology. Then we had Ethereum in 2015 that had a lot of generality, and Ethereum essentially provided to run anything, as a smart contract on the Ethereum blockchain. So a very general computer compared to Bitcoin that is only a limited set of instructions. And then we had Polkadot, and Polkadot provided performance, these cores. The ability of processing data coming from different chains at the same time in a very scalable way without all the nodes to check everything all the time. Because we noticed that each core has only 5 validators. But then there is a very clever process underneath of escalation that if something bad happens, all the validators are called to action, right? And this was Polkadot 1.0. Then we had another upgrade this year of Polkadot 2.0 that is still ongoing because elastic scaling has still to come to Polkadot. But this accessibility is already here because we have this agile core time that allows to access Polkadot in a more agile way, more democratic, and allows to do any kind of experimentation on it. So it's not a very elite kind of user that has to access Polkadot with with this auction model, but now everybody can buy core time and run something on Polkadot. What is the problem? I think, or better, what can we do better? What is Gavin communicating to this during these talks that I've noticed is that Polkadot is a heavily parallelized chain. It's called sharded. It's a sharded chain, and each shard essentially is it's one rollup, one chain that is connected to this core. It's a permanent connection, in a sense that there is never a point where 2 chains can communicate together within the same core. We cannot share these cores, and this can be kind of a problem because this it is not possible, for example, to execute. It's not possible to have 2 chains that are executed in the same Polkadot relay chain block, right? It's called that is it's kind of like a system that is not synchronous. It's synchronous. I mean that it's all executed in 6 seconds in the same relay chain block of Polkadot. This is still not possible to have these 2 chains that are doing this. It's asynchronous. It means that you need to use this interoperability that Polkadot has, because you can still communicate between chains, but this will take some time. So this coherency problem is what made Ethereum very popular, because it is possible to have different smart contracts communicating at the same time in a very synchronous way. And it's also what made Solana very popular, because Solana is a very, very coherent system, where you know, it's not a sharded chain like Polkadot. So it's very easy to do things very fast, right? So this is actually what Polkadot is it's missing at this stage, and this is what Gem is aiming to solve. So essentially, you know, bringing back a little bit to the diagrams, kind of, you know, to a diagram, we can have like different cores. You can see here, right? Here we have different cores, and these cores can actually fetch data, but also push data to a very, you know, beefy version of the current data availability system. And after that, this data can be accumulated and then pushed to the Gem state. So I don't want to go too much in detail here about how it works, but Gem also provide a lot of generality. I would say, like, on top of the fact that it's providing a possibility of different chains to be synchronous and to cooperate in the same core, it's also providing, is also like abstracting away a little bit. I mean, not a little bit, very, very heavily, the use case of these cores, because now only rollups can use this cores, but with Gem, anything can run on this core. And here is like it's written like work packages. Essentially, work packages is what is going to be pushed to these cores. But this work package, there can be from different services. So we don't have Parachains anymore. We have services, and there is the Parachains service, which is managing all the current Parachains. But then you can have also other services, and creating services is permissionless, and everybody can create a service. You can have a contract service, so you can run a contract on the cores. And you know, the limit is really like the human mind here. You can, since like you can create services in a permissionless way, you can really be quite creative and propose exotic things. And this is really what Gem provides to Polkadot. There is no more only parachains. There can be many different things, and this is kind of in the service kind of realm. And then you also have the possibility of have this synchrony, but this synchrony is not forced, because Polkadot will always be a sharded chain, a permanently sharded chain, but now not very permanently sharded, in a sense that is, you know, transitory, coherent, in a way that if you want, you can schedule the process within the same core. You can share at the same time that core with another process, maybe a chain with a contract, and have all these different things being executed at the same time. This also creates the possibility to use meta, to build meta application, and have application that really the user doesn't even have to know that that application is using different chains that are synchronously, you know, executing stuff together with I don't know, with a contract, and you know, these kind of things. So it's a very it's a very revolutionary, I would say, system, because if you want to scale, you have to think that if you want to scale a blockchain, you cannot rely on a coherent system. After some growth, it will be problematic to manage this data. So it's a very you know, what has also been doing in the history of computing is like sharding allows to put data in different parts and do different things with this data. And it's a very, you know, it's a very efficient way of scaling. But at the same time, you might have some problems. In this case, the problem of having an asynchronous system. So this possibility in GEM to schedule and share these cores like traditional computers do, it's a very revolutionary thing, and I would say like it's something that history has already taught us in the computing. So that blockchain is, because Polkadot is a decentralized supercomputer, it makes sense to have this this possibility, this semi-coherent system where you're not forcing the system to be coherent. You can actually scale it very well, but you give the possibility through incentives to do so, to schedule processes synchronously. So this is just a summary of why GEM, right? Say a more coherent system, possibility to have this synchronous thing, this shared cores. This core play is kind of, I don't want to go too much in detail in this, but it's kind of like a pause and resume later kind of thing. So it's a possibility to have ongoing programs, but even if there is some asynchrony, so it's kind of like traditional computing. So it's a possibility to have long-running processes, but the possibility to stop and resume later, right? Then you have the simpler chain specification, because we have this join and accumulate. I mean, this, I would like to go back here. We have this refine. Refine here, you can see this is actually a function. Refine stage that is in core, that what is done within the cores. And then we have an accumulate function. It is what is done on chain. This is actually very, very interesting, because in most blockchains, validators are actually updating the state of the chain. Here, validators, they don't necessarily do that, right? They have different roles. Some validators are in the core, some validators are distributing data, and then some validators are writing into the state. So it's a very, very efficient way of using this computation, these machines. And yeah, this subscription kind of thing, like this pays-as-you-go model, this core time model, where you can access cores very, very agile in a very agile way, and actually, capitalize on this, because you need to use DOT, and these DOT are burned. So it's kind of a revenue for the blockchain, and it's creating, I mean, depending on the usage, but a deflationary pressure on the token. It's kind of interesting. And I will be surprised to see how this thing goes. And it's a performant and coherent system, but not it's not only transitory coherent system. It's not permanently coherent, and it's a very secure and flexible and accessible block space. And it's for everyone. This is important. Now Polkadot is not for everyone, so this will allow Polkadot to be for everybody, not only for parachains, for anything that you want to experiment. If you want to use this secure and decentralized computers, this decentralized computer and computing power that Polkadot provides, you're free to do so. And Polkadot is of the community. I want to remember the people that Polkadot has the biggest governance, this OpenGov. That has been, there are good and bad things, a lot of stuff in the social, of course, like this thing generate always a lot of noise, I would say, but it's of the people. It's for the people, and people can decide the fate and the future of the network. So the end goal is really to shrink this kernel that you can see here even further, to put the Parachains protocol in here. So to make the user land as fat as possible, and to make the kernel as thin as possible, so that it just does what it needs to do. All the rest is managed here. You can see like this user, we can have different services, right? Each of these blobs here, these are different services. We can have the core chains. This is all the parachains. And we have the governance, the staking, the DOT token, and all the stuff in one service. but then we can have the core play service and, you know, whatever people come up with. Here is just a screenshot of my M1 MacBook Pro, just to show how traditional computing works. This is actually where Polkadot is going, right? You can see you have different core. Maybe one is an efficiency core, one is a performance core. You can see like in red, there are system processes that are running together in the same core with a parachain. So this is actually where GEM is going, right? Where this vision is actually going. The possibility to recreate whatever you know, the management of a traditional hardware in your computer, to do the same thing with a decentralized blockchain-powered computer like Polkadot. And this is actually the end holy grail of blockchain, I think, because this is actually how what it allows, you know, a network, a blockchain network, to actually scale and accommodate what is possible to do for really a lot of users. And yeah, if you want to know more about Polkadot, I really recommend to scan this QR code. You go to the Polkadot wiki. The Polkadot wiki contains really a lot of you know, information about Polkadot, not only to learn, but also for maintainers, for builders. Please go. If you have any, you know, if you have any question, reach out to me at Filippo Web3 on X, or, you know, especially you can reach out to me on X, and I will be happy to implement, you know, any critique. You can also go and post an issue on the GitHub page of the wiki. The wiki is an open source documentation. You are free to add an issue, or to even like to propose a pull request. We will be happy to review it. I'm really, really glad to see the community building the wiki as well. And yeah, thanks a lot. I hope you enjoyed this 40 minutes, and we still have some time for questions.
Absolutely. Thank you so much, Filippo. We have got a few questions in the chat and the question tab. Just quickly, I'll cover one of them. Will we have access to the recording? Yes, you will. It will be available tomorrow, so you can rewatch all of this session if you've missed any of it, or you want to rewatch some of it. I think someone said they'd be rewatching one of the sections. So in terms of order of questions, we can start from any of them. The earliest question we got was, which core time connection is more efficient, interlacing or splitting? Is there some latency in changing chains?
Ooh, this is a good question. I don't know right now. Unfortunately, on Polkadot, we still have like the auction model. On Kusama, we have still like, we already have, which is Kusama is essentially the Canary network where these things are tested. But I don't really know. I mean, this, I would say like using one or the other might be related to this, like this latency things. But it might be also, you know, because you want to have a long-running process, and you need to process these blocks constantly, but you don't need to do it every 6 seconds, for example. You might want to interlace it, but if you're splitting it, it means that after that, you're not doing anything. If you're not scheduling on another core, you know. So I think here it's more kind of also a use case or usage of your chain. Maybe your chain stops to have some users because it's a kind of like a temporary thing, or a seasonal. So you don't need to use this course all the time. You just split it, and then that's it.
Nice, good question from Saffron. Adam has asked, would it be possible for a wealthy highest bidder to potentially take over and monopolize a permanent core chain connection, and in effect also block others from this connection?
No, I think the maximum number of cores that you can access is 3. But okay. I will need to check this. No, but definitely not. I mean, of course, like accessing a core will be more economical than winning an auction. This is the whole idea, is to make the possibility to access this core, as easy as possible, but at the same time to avoid the situation where one person is just buying all the core time.
Yeah, that makes sense. Saffron again, possibly the same person as before, has asked, can you explain more about elastic scaling? I know it's coming up, but I haven't understood what it's going to do.
Essentially, elastic scaling allows to use multiple cores at the same time. So you can push data on multiple cores at the same time. Maybe I can put it in another way. Let's say that you have a lot of data on your chain and you are using a core, right? But you have a lot of usage. So whatever you're using on that core is maxed out. You cannot push more than that. So the possibility that you can do is buying core time on an additional core. But at the same time, you will need on the Parachain side to a very beefy collator, a very beefy block production, because the relay chain clock spins always at the same time, right? I mean, it's always the same the same clock. But because you're using two cores and you're pushing twice as data now on your lane, which is a single lane, you need to produce a lot, right? You imagine on the Parachain is like boom, 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 and then boom, boom, boom on the relay chain, right? But at the other side, you have to have beefy kind of components, right? But this is only for chains that have a lot of usage. It doesn't make sense to reserve to use elastic scaling if you are not even using your own core at the maximum. So the possibility that you can do is just to use agile core time. So the opposite scenario is that you don't need all this computation that you have on a core, and you just share it. No, not share it. Sorry, you just interlace it or split it. So it's never sharing at the same time. This will become possible with Gem, but here you can interlace it or split it if you don't have enough usage.
Thank you. Edgar has asked, I've missed a question. Husni has asked, if untrusted code is pushed into the core, how do the core validate whether the code is malicious or not? And if one creates a parachain service, how does the system validate the state transition?
So first, the rollup system, the cynical rollup system, is checking that whatever you send to Polkadot is correct. So if there is any problems, and even if these 5 validators on the core, they are all malicious, there is a secondary checks I didn't talk about. So after the backing, after the inclusion, there are secondary checkers down the line before it is actually, it's all finished. The whole process is finished. There are still secondary checkers. And if one of those checkers spots, then the malicious actors can be slashed. I mean, they're slashed, and nothing is getting finalized on the relay chain. So this rollup system is actually what it does, right? It's just replay everything that has been played by the collators or by the validators of the rollups, and making sure they are all correct. And regarding the service, at this stage, unfortunately, I don't know how to answer this question. I know that creating a service is permissionless, but can you repeat exactly what was asked again?
If you can see the questions tab, it's the question from Husni. It's 4 down from the top.
Where is the question tab?
In the bottom right corner.
Oh, yeah, okay.
Let's see.
If untrusted code is pushed into a core, how do we core? Okay, and if one can create a parachain service, how does the system validate? When you create a service, you also have to specify this refine and accumulate functions. So all the time that you specify the service, you have this refine and accumulate function. So whoever creates the service permissionlessly, it has to specify this function. And then when you specify it, I guess that the system can validate anything that is coming through that service. But how exactly this is done, I don't really know. And I know that there are already some teams that are working on implementing GEM in different languages. There is also the GEM prize. If you out there are really interested in coding GEM using the gray paper, I really recommend you to go to the Web3 Foundation website and see at the GEM prize. It's a good way to develop and get your name out there. I think also whoever will implement this will also automatically be granted into the fellowship. So it's a good way of getting into the Polkadot ecosystem as a developer.
Yeah. Very nice. We've got a lot of questions. I'm not sure if we're going to be able to get through all of them. Edgar has asked, from the validator's perspective, they use Grandpa, Aura, and gossiping for sharding and to validate the data between other validators in other cores. If no one uses a core, do validators remain idle and work once they receive gossip?
Yes. If that core is not used, then those validators will participate to all the rest of these roles. They will not. They will still like participate, receive the data availability things. So they will still data from the other core, and they will still participate, for example, in secondary checks and finality.
Nice. Kent has asked, will GEM require a different smart contract compiler from Polkadot 1.0 and 2.0?
Where is the question?
Just about 3 from the top in questions.
Okay, will GEM require a different smart contract compiler from Polkadot 1.0? But Polkadot doesn't have, the relay chain doesn't have smart contract capability right now.
So technically, yes, but that's because there is no smart contract compiler for Polkadot 1.0 or 2.0.
Yeah, it would be I don't think it will be something similar to what are smart contract on Ethereum. I mean, on Polkadot, we can still like deploy smart contract on EVM compatible chains. Moonbeam, A-Star, you can still like deploy smart contract there that are Ethereum smart contracts. I feel that the contracts that you will be running on Polkadot will be a little bit different. So here again, I'm not really. Maybe it would be good to have. Are these questions recorded somewhere? Would be possible to get this question in written format? Because I would be happy. I would be happy to go through them and get back. Maybe on the socials or.
Yeah, that would be amazing.
Actually, these are actually good questions.
I can send you all the questions after, and we can compile some answers to send out to everyone.
Thank you.
We've got 5 minutes, so maybe we can cover these last 2, and there's a couple in the chat as well. Yes. Simon has said, Agile call time, will it be like, I think this means Ledger as a Service, AAS, with Jam, the actual model that Parachains rent slots in the relay chain will go to migrating to a renting core services?
So we Jam the actual. The Parachains rent slot in the relay chain will go to migrate. Is this kind of a agile core time?
You can answer
the whole idea is to make Polkadot I would say block space as a service. So what actually blockchains offer, the real value of blockchains is the space in these blocks. It's limited, which already means that can have value. Can have values if it's also flexible and it's secure. So however you can make better the access to this and use in the best way as possible the space on these blocks. It's like the end solution, right? And how we do this, you do it with these cores, because chains are connected to these cores, and with agile core time, you provide the possibility to really utilize this computation, this core computation, the best possible way.
So we still have 4 minutes because I quickly want to do an announcement at the end. Adam has asked, do cynical rollups require significantly more gas than optimistic rollups?
That's a good question. Cynical rollups, it's already what Polkadot is doing. So it's already live. It has been doing since 2021. And I would say that now these rollups are heavily subsidized by dot inflation, because essentially the fees on Polkadot are very, very little, right? And very minimal. But the validators are paid from the inflation right now. So actually, the inflation is what allows Polkadot, if you want to see in that way, to be to provide this service and not to pay that much for it, right? Essentially. So I would say that where in the future this is going, it's still not really clear yet. But of course, you want to generate revenue. You want to make sure that because this cynical rollup is always checking, this is a service and you have to pay for it. So I think like the core time and the burning of revenue is already a good start.
And one last question that is in the chat. Wario has asked, what's the difference between system chains and parachains?
There's no difference. It's really like they're all rollups. System chain are just kind of official chains of Polkadot, in the sense that you still use the dot token and you have the same address that it's on the relay chain. And it's just to offload these processes that are core, for Polkadot, that are system processes. But essentially, they're all rollups, right? It's just that in my talk, parachains, I was referring to these chains that are not system chain.
Yeah,
it's just to make the distinction.
Mm-hmm. Yeah, I think that makes sense. Hopefully that answers Wario's question. So we are out of time because I need to very quickly make an announcement. But thank you very much, everyone, for all of your questions. They've been really interesting. And thank you, Filippo, for that presentation and for answering everyone's questions.
Oh, thank you. I hope that was not too technical. I mean, in this case, it's impossible not to be, but I really enjoyed, and thank you very much for inviting me.
Yeah, we've loved having you. I mean, from all these questions, clearly everyone has found it really interesting and has understood it to some extent, because otherwise they wouldn't have questions. So that's amazing. So this is bringing us to the end of our Encode Polkadot Educate series. But what is coming up next is the Encode Polkadot Inc. Bootcamp. So this is a free bootcamp with sessions on the Inc. programming language, so Inc. smart contracts. So if you want to sign up for that, in the email that I sent before this session, there is the registration link. The sessions will be run in a similar way to these workshops, where we'll have technical speakers coming in, but it will be more technical focused with live coding and room for you to ask questions about that. And this is in the run-up to the Polkadot Hackathon coming up very soon. So definitely sign up for that if you're interested in the more technical coding side of Polkadot, especially if you've enjoyed the overview workshops that we've done in this Educate series. It would be great to see you coming for the more technical ones later. Thank you very much, everyone, for joining us. Hopefully I'll see you all in the boot camps, and enjoy the rest of your day.